So what's going on, guys? So it's been a little while since we did an actual welding video. And the reason being is we've had so many freaking Jeeps and Silverados, and I think we just got done with our third Silverado. We got 2 more Jeeps to do. So we're screaming on that work. And every now and then I like to show you guys a little bit something different. And today is somewhat different. We've done a video on repairing a motorcycle case previously, but this one's a little bit different. So if you guys can see this, which I'm sure you probably can or can't, this is where the sprocket goes. Now what happened was the bearing that goes down inside here wore out, and the shaft was just kind of, you know, this is the shaft here, it comes up through that. Just kind of doing one of these and wallowing around, and with the chain on it and everything else, it was pulling it to one side, which was to the rear. So you can see that's where the, you know, the majority of the damage is, right in the rear. Sounded disgusting. But in the back of the case, the damage is significant. Now, the problem we have is inside, you can see that there's a bearing diameter in there, and that bearing diameter is still okay. What's not okay is this outer diameter, which holds the lip seal. Now, in order to get that lip seal back in there, we're going to have to weld around this whole thing and build this back up again. And I don't know if you guys will be able to see it, but we'll try. We got to weld around this. We got to bring this diameter back up again to a height that's about the same as what it is on the front right here. And then once we do that, I'm going to overbuild this a little bit. And then we went ahead and built a tool. And this is when it's nice to have a lathe and a Bridgeport. Now, getting the diameter of this correct for this seal is tough because you can't put this in the lathe. This has to be perfectly circular. And we have really no way of putting it down on the Bridgeport and then spinning it around. We only have a fixed option, so we can fix it to the table, and then we had to come up with some sort of an option. Now, being that this is a strange size, the seal is a strange size. I think it's 1.675 inches, which might not be a strange size if you do the math, but to me it's a strange size. I don't have any kind of cutters or anything like that that are that size. So what we did was we went ahead and threw this on the lathe, turned it down to about 1.163, which is 2,000 smaller than what the actual external size of the seal is. And then we cut some grooves in it with the Bridgeport so that it almost looks like a drill bit. And then we filed down each side, like you can see here, so that we literally only have a cutting edge here and a cutting edge here. So what we're going to do is, once we get this all welded up, we're going to take it over to the Bridgeport, we're going to mount it, we're going to center it up as best as we can, which it has to be pretty close for this lip seal to seal, but we have 4 or 5 thousandths in either direction, so we'll be okay. And then what we do is we chuck this up in the Bridgeport, we come down in here, and we can literally utilize this tool to bore out the weld hole, or the weld that we just made, to hopefully get the perfect size seal. And once we get the hole in it and we know the seal fits, then we can machine this top surface back down to a, you know, a regular height. But this will allow us the stability and the strength in the Bridgeport so that once this starts coming down, it doesn't want to walk and it doesn't want to move or whatever. So just a big chunk of mild steel, which in this case, mild steel is not going to matter because we're cutting aluminum. So we don't have to harden this, we don't have to do anything. We're probably only ever going to use this tool one time. We got some nice sharp edges on it, and we'll be able to kind of pound through this aluminum pretty quick. And yeah, so let's go ahead and weld this up, get the weld on it, and then we'll take it over to the Bridgeport, chuck it up, see what we can do. Alright guys, as I'm sure you can see, this is some pretty gnarly cast aluminum. You see it popping and spitting and doing all kinds of stuff. We're going to run into that, so we're going to lay a bead around it, we're going to clean it up, then we're going to go back over it just to make sure that we got decent penetration into this cast aluminum. But this is the crap that you deal with this dirty cast, and I cleaned the crap out of it before we started. So let me finish this up and then we'll clean it and we'll go again. Alright, I'm going to take it over to the wire wheel, and we're going to clean this up because it's pretty bad. Alright guys, so now we got this thing nice and clean. We're going to start doing some more build-up on it because we still need to raise this another 1/8 of an inch or so. And we're going to go all the way around to make sure that the inner diameter is also built up so that we can ream it back out again. So here we go. We're also going to want to keep a little bit of this inner diameter in here so that we have something to measure off of when we take it to the Bridgeport and try and center all this stuff up. So luckily we have a decent amount of the seal surface still available, and we'll be able to kind of get an idea and gauge and get it, you know, as close as possible to center, and hopefully we'll hit it on the money. Alright guys, so a little rule of thumb that I like to use when you're building something back up again is when you think you've got enough material, add more. And that's, you know, that's one thing I can tell you, because even between all these nice little fancy ripples and everything, you know, you've still got some voids and some areas that that might be devoid of filler material, and you know, you still want to keep going around and building this thing up to a point where you get it, you know, really good size to where you can just machine the rest of it off. And that's the thing, is you can always grind it off, but after the fact it's very hard to weld the stuff back on. So if we go ahead and we bore this and we machine it, we find out we need more material, we're kind of screwed. So we got to start the process all over again. So when you think you've got enough material on it, just add a little bit more, and that little bit more will give you what you need. And again, you can just cut it off or grind it off or machine it off or whatever you want to do. So keep going until you feel like you're good, and then add a little more. So now, as you guys can see, as we are adding new filler metal, we're getting less and less of that popping and that, you know, nastiness and everything else. So that's what we were looking for. Now we've successfully built up around where we need to build up. I'm going to build up a little bit back here and a little bit around this outer edge out here. Again, you can machine all this stuff off. I just want to make sure that we have enough when we start boring down into this thing, and that, you know, we get our diameter pretty well centered. So we may even, I don't know yet, but we may even kind of bore from the back side, because the back side of this still has a little bit of the bore left. We'll be able to center it a whole lot better. So we may literally just start from the back and punch through, and hopefully that'll get us the centering we need without being too far off. But for now, let's just get the rest of this thing welded up. You can tell there we're kind of back into that whole popping, spitting, and farting thing again, because we're back into the actual cast aluminum. So I think that'll probably give us about what we need material-wise. Just check on the other side. Yep, I think so. So you can see that seal bore in there, and you can see the material right here is bigger or smaller than that seal bore, and that's exactly what we want, because we want to be able to dive down in there with the tool that we made, come in through this way and actually get into that sealing surface and center it up and then bore back through the weld that we just put in. So what we're going to do now is, these cases are super finicky. They're super sensitive to heat and everything else. So I am going to set this down and let it cool completely before doing any kind of machining whatsoever, because we do not want to crack this thing. Nor do we want to clamp it down while it's hot, because it'll do all sorts of weird stuff. So we're going to leave it on this nice flat table, and as it cools down, it'll level itself back out. Then we can set it up probably on this surface here, upside down on the Bridgeport, clamp everything down, and then see if we can't bore through it. Alright guys, so for the most part we are set up 100%. We're within a couple of thousandths of the original sealing surface. So we are now ready to start boring this out. We're going to go super duper slow. And we're just going to take a little tiny bit at a time here and there to make sure that we get everything we need. And we should be pretty good. So let's just do another pass to make sure real quick. And so far we're looking pretty good. I mean, we're just a hair off, a couple thousandths maybe. Yeah, so we're looking pretty good now. So we're going to go ahead and pretty much send it. Using very light pressure. Alright guys, we're almost all the way through. Alright, so we made it all the way through. And I think we're going to be good, if you guys can see any of this. Let me get you straightened out here. But you can kind of see now we have a pretty straight hole through there. Our tool did exactly what we wanted it to do. And now I left a little bit of extra room for some cleanup, so we're going to take all of these mounting points that I put on here to hold this thing in place. We're going to take all this off, pull it off the bench, and see how our seal fits. So we went and cleaned everything up. Got it looking as decent as possible, and you can see the lip seal fits in there nicely. Now, one of the things I want to bring you guys attention to is you notice these inclusions that are in here, and that's just the nature of the cast material. When you weld it, you're gonna have some porosity and some empty spots and whatever. So I left the tolerance on this seal just a little bit loose, so it literally is like a thou too loose. I did that because if you try to press the seal into this particular bore that's not super clean, what's going to end up happening is it's going to tear the end of the seal. So what we're going to do is we're going to put the bearing in, make sure that seating surface is good, then we can set the seal down and we can actually silicone the seal in and it'll hold it perfectly. We just wanted to make sure that we had some room in here and that we weren't off by any means, and the original diameter was so messed up that we actually had to go in here and add weld material in. So you're never going to get it perfect unless you have the machine tools to do so, which in this shop we don't have. So if you're a machinist and you just watched all this, I apologize for what you saw, because it is not even close to what should be done. However, when you have limited tools, I wouldn't say limited, I mean a Bridgeport and a lathe isn't necessarily limited, but if I had an adjustable boring head, we could have bored this and then bored it again, and got it to a nice press fit with a super nice finish and everything else. However, what this job pays doesn't warrant me buying, all of that equipment. An adjustable boring head, a good one, you're probably looking at, $200-300, and I'm not making anywhere near that on this job. So we do what we can. What's going to happen is we'll get this in here. We'll get it siliconed in place, which you won't even see the silicone because it's just going to be around the edge of the seal. And this thing should never come out. It should be absolutely fine. All right, guys, so there it is. The seal is in. Sorry for the shadow. But the seal is in, and it is, we used a little bit of ultra black and just kind of pressed it in there. Now, what we'll probably do is, just because of the way that this is and the side cases and everything else, I don't expect this thing to last forever. Probably going to eat that bearing again. It's probably going to go through another, and at that point, you know what, he's gotten the life out of the case. He can buy a new case half, and hopefully by that time this case half will be a little bit cheaper. Now, the reason we fix this is because it's intensely cheaper to do a quick repair on it than it is to replace it. I think it's $400 or $500 for this case side. Now, the longevity of this is still to be determined, because you got to remember there are some issues, some casting issues that I saw. There's a few other odds and ends, so who knows? You might smoke that bearing the first ride out. You might not smoke the bearing. We don't know if this case is 100% true, if it's running off, and that's why the bearing let go. So there's just a ton of unknowns. But what we're going to do is, once the silicone in here dries, we'll let that dry overnight, and we'll come in here with a little center punch, and we'll basically stake all around this seal. And what that'll do is it'll push the aluminum into the edge of the seal, which will then hold the seal in completely tight. Because remember, like I said, our cut wasn't perfect because our tool wasn't perfect. And so we have a little bit, maybe a half a thou of clearance between, the whole circumference of that seal, which is easily taken up by silicone. It's not that it's drops right through. It is literally a fit, but it's a perfect fit and not a press fit. So we did get it good. We're going to stake that once it's done. We put the actual gear shaft in and made sure that everything sits the way that it should, along with the seal riding surface. This actually goes down into the lip seal itself, and that's what the seal rides on. So we're good there. And yeah, so that's pretty much it for this one. All right, guys, I hope you enjoyed that one. I hope brought you a little bit of info, maybe something a little bit cool. It's probably rare that you'll ever do something like this or need to ever have something like this done. Normally you just buy another case half and call it a day, because this one was pretty mangled. But we managed to get the bearing back in. We managed to get a halfway decent sealing surface. We managed to get all of the, everything that was wrong with this case half fixed. And I think we're good. I mean, we had to make a tool. We had to do a few other odds and ends, and it all ended up working out. I wish I was filming actually making the tool, but I totally was spaced out and said, oh, you know what, I should film this. And of course started filming after I made the tool. But you guys get the idea, what you have to go through to give people an inexpensive alternative to, do this. I think the whole project in total probably took about 2 hours. And yeah, it's not too bad. So now he can rebuild the rest of this, put new bearings in the rest of it, and hopefully it'll hold up for a while. My guess is it'll hold up for as long as the first one held up for, which wasn't long to begin with. So we shall see. But hope you guys enjoyed that one. Hit that like button. It super helps out. Hit that subscribe button. We just hit 22,000 subscribers. We've gained 1,000 subs in the last 28 days, which is pretty significant for this channel. It's moving. So cool. All right. So if you are the one, I believe it was Emmanuel, you are the one who won the scan tool or the code reader from the video previous, hit me up in the email that I commented on and let me know where to send this thing to so you can get your scan tool. And yeah, we'll see you guys on the next one. Have an awesome night.